This presentation showcases UIUC's design for the 2020 ASME Student Design Competition. Our team started the design process with some initial brainstorming. We began by playing around with paper to see which towers could be built the strongest, the tallest, and the easiest. We attempted to come up with as many ideas as possible in this stage. When it was time to narrow down ideas, we decided that we wanted our paper to not need any creases. This allowed for the paper to be fed into the robot as its final shape. We next realized that all of our towers had vertical layers. We observed that these layers were most balanced when they were interlocking instead of just stacked. Some ideas we had to interlock the pages included having our robot cut and fold the sheets together, or having a stapler join each layer. The last decision that we made was that we wanted two robots, one main robot and one to be used for only the strength competition on day one. After brainstorming, we made decisions on what we wanted the first iteration of our robots to build. Shown on this slide is our main design. Here each paper is fed around the previous. Then it gets stapled by the stapler to attach each layer together. Shown on this slide is our strength design. Here, paper cylinders are rolled and fed into the previous cylinder one by one. Then, these cylinders are turned upright and a weight is placed on the paper. Once we decided on our designs, we began prototyping. Shown on this slide is our first attempt at a paper feeding mechanism made from 3D printed rollers. These didn't have enough friction, so we instead decided to use Lego Technic wheels to feed our paper. We then ended up making a full prototype out of Legos. In this prototype, the red part is the stapler and the Lego Technic wheels are connected through a Lego gear train. As shown in the video, the wheels are able to guide the paper upwards directly through the stapler. The stapler works by cutting a flap into the paper and folding this flap under the rest of the page. Here's the simple prototype for our strength robot. It consisted of about 20 sheets of paper rolled together and could hold 4 cinder blocks, each weighing 30 pounds. Building and testing. The main robot design was first tested after the first few gears and walls were modeled and 3D printed as shown on the left. The strong robot was tested more thoroughly in this stage after we changed our design to maximize the space allotted for in the rules, as shown on the right. Here, 100 sheets of paper were able to hold 15 cinder blocks, or about 450 pounds. During testing, the majority of the issues appeared in our main robot. We first realized that the alignment of the paper wasn't very consistent when leaving the first set of wheels. This would cause the paper to hit the side of the stapler, which would jam the entire mechanism. The second big issue came about when the second sheet of paper was loaded into the main robot. This issue was that the wheels began to get pulled apart since the Lego Technic shafts are thin and the moment arm was large. We went through many iterations on the shown part to fix these problems. This part was first originally used to only hold the stapler. Then we added a funnel to more accurately feed the paper into the stapler as shown in the middle model. This funnel ended up being too jagged, and we also needed to fix the issue of the wheels getting pulled apart. So we created the third iteration of this part as shown on the right to smooth out the funnel and hold the shafts in place to create a smaller moment arm. Shown here is the completed CAD model for the main robot. The yellow part in the middle model is the part from the last slide. Shown here is the completed CAD model for the strength robot. The black part is a servo motor that turns the 3D printed cups 90 degrees. The blue part is the mount securing the motor. This is the final main robot. It consists of an aluminum base and 3D printed parts for structure, Lego wheels and a stepper motor for movement, and a stapler and linear actuator to interlock the sheets. As seen in the middle picture, each page is fed through the robot and stapler. This is the strength robot that we built. As seen in the video, each page is one by one rolled and inserted into the robot. Then, the 3D printed cups each turn 90 degrees using a servo motor. The weight is then placed on the paper. Cardboard and tape were substituted for aluminum and fasteners due to the inability to make purchases at this time. Here are a few videos of the main robot in action. The video on the left displays how each paper is fed and moves. The sounds that can be heard include the motor, which drives the wheels, and the linear actuator, which punches the stapler. Each new paper is then fed overlapping half of the previous paper to interlock the two together. The clip on the right gives a close-up view of this process. In this slide, the middle picture demonstrates how the robots would fit together when placed in a 50 centimeter cubed box. The left and right photos show how the main robot looks after building up to 1.5 meters and 2.55 meters respectively. Finally, this is a list of our best performances. We took 59 seconds to reach 1.5 meters in the speed round, we reached 2.55 meters in the height round, and we held 18 pounds in the strength round. Thank you so much for taking the time to view our presentation.